Good morning everyone. Myself R. Venkatesh. Today I am going to discuss about the components of modern block cipher. So coming to the concept, the modern block cipher. Okay, so the modern block ciphers are normally keyed substitution ciphers in which the key allows only a partial mappings between the inputs and the outputs. Okay, so the modern block ciphers is a combination of transversion units of diffusion. That means which is also called as D boxes, and substitution units, so which is also called as S boxes. Okay, that means the modern block ciphers are the combination of both the D boxes and S boxes. So you can see the D boxes here. So the D boxes are used to transpose the bits. Okay, that means you can rearranging the bits here. Okay, so it is referred to as permutation. So that's why it is also called as P box. So the system of output of the D boxes are predefined. Okay, so the mappings between the inputs and the outputs are already predefined. Okay, so there are three types of D boxes. The first one is straight D box, second one is expansion D box, and the final one is compression D boxes. So coming to the first one, straight D boxes. So a straight D box with n inputs and n outputs according to permutation. So there are n factorial possible mappings. Okay, so you can see the diagram here, straight D box. So we're having 5 inputs. Okay, so those 5 inputs will be forwarded to the P box. Okay, so now those 5 inputs will be mapped with 5 outputs. So those mappings are predetermined. Okay, so you can see the first input is mapped with the 4th output, and the second input is mapped with the first output. Again, the third input is mapped with the 5th output. The 4th input is mapped with the 3rd output, and the final 5th output is mapped with the 2nd output. Okay, so here the mappings between the inputs and the outputs are already predetermined. We cannot use any key here, so the mappings between the inputs and the outputs are already predetermined. So the D box is implemented in hardware, it is a pre-wired. If it is implemented in software, a permutation table shows the rule of mapping. Okay, so you can see the table here. So the table contains 64 inputs, 64 bits. Okay, so from 1 to 64. Okay, so the entries in the table are the inputs and the positions of the entries are the outputs. Okay, you can see the table here, a straight permutation table when n is 64. Okay, that means the table has 64 entries corresponding to 64 inputs. Okay, so the first bit you are having the first bit having 58. From the 58th bit I am getting the first output. Okay, is it clear? From the second place I am having 50. That means from the 50th input I am getting the second output. From the 42nd input I am getting the third output. Like that the bits will be arranged. Okay, so the position of the entry corresponds to the output. Okay, so the first entry contains the number 58. You can see the diagram. Okay, so the first entry contains the 58. Okay, so we know that the first output comes from the 58th input, and the last entry, that means 64th. Okay, so the 64th bit contains 7. Okay, so that means the 64th output comes from the 7th input. Okay, so like that the bits will be arranged. Okay, you can see the possible mappings of a 3 by 3 D box. Okay, so we are getting 6 permutations here. Okay, you can see the diagram, we are getting 6 permutations. So next one is compression D boxes. So a compression D box is a D box with the n inputs and m outputs where m less than n. Okay, so some of the inputs are blocked and do not reach the output. Okay, so in the straight D box we are having 5 inputs and we are having 5 outputs. Okay, so the mappings between those inputs and outputs are predetermined. So coming to the compression D boxes, so you can see the diagram. So in the diagram I am having 5 inputs whereas I'm getting only 3 outputs. Okay, so in the 5 inputs, the 2 and 4 will be blocked. Okay, so the remaining 3 bits, that means 1, 3 and 5 are mapped to 3 outputs. Okay, so that means we are having n inputs and m outputs, where m is less than n. Okay, that means the outputs is less than inputs. Okay, that means a table for a compression D box has m entries, but the content of each entry is from 1 to n with some missing value. So you can see the example here, 32 into 24 permutation table. Okay, so here from 1 to 32 bits, we are having 1 to 32 bits. Out of those 32 bits, we are missing 8 bits. Okay, so the inputs like 7, 8, 9, 15, 16, 23, 24 and 25 are blocked. The remaining bits are represented in the table. Okay, that means we are having m inputs. Okay, that means 1 to 32. Okay, so those are the inputs, but I am getting only 24 outputs. The remaining 8 bits are blocked. That is compression D box. The next one is expansion D boxes. So an expansion D box is a D box with n inputs and m outputs, where m greater than n. Okay, so this is quite opposite to the compression D box. Okay, so in the expansion D box, we are having 3 inputs and we are getting 5 outputs. So you can see the diagram here. So I'm having 3 inputs, 1, 2, 3, but I'm getting 5 outputs. Okay, that means the mappings between the inputs and outputs are more. Okay, so some of the inputs are connected to more than one output. Okay, so you can see the example here. Okay, so the table of 12 into 16 expansion D box. So each of the inputs 1, 3, 9 and 12 is mapped to 2 outputs. Okay, next one is invertibility. So a straight D box is invertible. This means that we can use a straight D box in the encryption cipher and its inverse in the decryption cipher, because we are having same number of inputs and same number of outputs in the straight D box. Okay, so the straight D box is used in the encryption process and the inverse of the D box is used in the decryption cipher. Okay, so here you can see the inverting the table. Okay, so in the first you can see the diagram. Okay, so the first step is horizontal table. So I'm having 6 elements. Okay, so 6, 3, 4, 5, 2 and 1. Okay, now the second step is add the indices. Okay, so for the 6 elements, okay, so I'm adding the indices. That means the positions of the elements. Okay, so the first position represents the 6th bit, and the second position 3rd bit, the 3rd position 4th bit, the 4th position 5th bit, the 5th position 2nd bit, and the 6th position is 1st bit. And the step 3 is swapping the contents and the indices. Okay, now we can swap both the contents and the indices. The finally is sort based on the indices. Okay, so you can sort the elements based on the indices numbers, and finally you can get the inverted table like 6, 5, 2, 3, 4, 1. Okay, so the compression and expansion D boxes are not invertible. Okay, so because in the compression and expansion D boxes, we are having different types of inputs and different types of outputs. Okay, whereas in the straight D box, we are having same number of inputs and same number of outputs. Whereas in the compression and expansion D boxes, we are having different number of inputs and different number of outputs. So the next one is substitution box. Okay, so an S box can have different number of inputs and outputs. So an S box is a m into n substitution unit where m and n are not necessarily same. Okay, so the substitution is used for replacing the bits. Okay, so the plain text and cipher text having different types of different number of ones. Okay, so the number of inputs and outputs are not necessarily same. Okay, so again the modern block ciphers uses keyless S boxes where the mappings from the inputs and the outputs are predetermined. So you can see the expansions here. The relationship between the inputs and the outputs can be represented as a set of equations. Okay, so y1, y2 and so on yn. So these are the outputs, and I'm having x1, x2, x8. So these are the inputs. Okay, so again in the linear S box, this can be represented as like this. So y1 equal to a11 into x1 XOR with a12 into x2. Like that, you have to perform the operations. The next one is invertibility. So the S boxes are substitution ciphers in which the relationship between the input and output is defined by a table or mathematical relation. Okay, so you can see the diagram here. I'm having two tables. Okay, so if the input to the left box is 0, 0, 1, so you can consider the left diagram. Okay, so the first row is 0 and the column 0, 1. Okay, that means if the input to the left box is 0, 0, 1, 0 from the row and 0, 1 from the columns, you can take the input like that. Okay, so the output will be 1, 0, 1. Okay, you can consider the input 1, 0, 1 in the right table. Okay, you can consider the second table. So in the second table, so the input is the row, you can consider 1 and the column is 0, 1. Okay, so the output is 0, 0, 1. That means, which shows the table are inverse for each other. Okay, so from the left table, so when we are giving 0, 0, 1 as input, I'm getting 1, 0, 1 as output. In the right table, when we are giving the input as 1, 0, 1 and I'm getting 0, 0, 1. That means these two tables are inverse of each other. Thank you so much.